Alright, so let's look at some trigonometric integrals. This is the second video, my second example. Uh, these guidelines here, I read through the guidelines and kind of explain what's going on in the first video, the example 1. So if you want to hear that, then go back and watch the first part of the first video. But in this video, we're going to use this second one here, okay, where we're gonna pull out a factor of cosine here, and the cosine squared that's left over we're going to convert to 1 minus sine squared x. Alright, so let's take a look at that example. Alright, so in this example I've got cosine cubed x over square root of sine x dx. Alright, so notice the power on the cosine is odd, so I'm going to pull out a cosine, okay, and kind of save that. So I've got cosine squared x over, now this sine, the square root of sine x, I'm going to rewrite that as sine x raised to the 1/2 power. Okay, and then that's going to be times cosine x dx. Okay, this is because, you know, cosine squared times cosine, that's the cosine cubed. Okay, alright, so now what I'm going to do is I'm going to rewrite this. I'm going to have sine x to the negative 1/2, I'm going to bring it up to the numerator, times cosine squared x times cosine x dx. Okay. Now this cosine squared, I'm going to rewrite it as 1 minus sine squared. Okay, because we know we've got sine squared x plus cosine squared x equals 1. And if I bring the sine squared x to the other side, that gives me cosine squared x equals 1 minus sine squared x. Okay, and so that's where that's coming from. Alright, let's erase this. Alright, so this is going to be sine x to the negative 1/2, and then this is going to be 1 minus sine squared x times cosine x dx. Alright, so hopefully you can see now why we're taking out this cosine x and putting it over here with the dx, because what this is going to let me do, you see the sine x and then the sine x squared here, I can let u equal sine x. Okay, well, what's the derivative of sine x? It's cosine x, and see, there's that cosine x. I'm rewriting this in like this so I can use u substitution. Okay, so we're gonna, let me change colors here. Alright, so I'm gonna let u equal sine x, and so du is going to be cosine x dx. And you can see now that I have my cosine dx, my cosine dx, I can put du in the place of that, and then for the sine x, there's a sine x and there's a sine x. Now remember, sine squared x, that's the same thing as sine x, all of it squared. Alright, and that's really what we're doing with these things. We're wanting to rewrite them so we can use the u substitution. Okay, and so I'm going to replace sine x with u, so that's u to the negative 1/2 times 1 minus, and I'm going to put u in for sine x, so that's u squared. And then in the place of cosine x dx, I'm going to put du. Okay. Alright, so now let's go ahead and distribute the u to the negative 1/2. So that's going to be u to the negative 1/2 minus u to the 3/2 du. Now I can just use my power rule here, and so I'm going to add 1 to the exponent, that's u to the 1/2, and then multiply by the reciprocal, so times 2, minus, and then that's going to be u, I'm going to add 1, that's to the 5/2, and then multiply by the reciprocal, so times 2/5, and then all that's plus c. Okay, so once again, I can't leave my answer in terms of u. I have to put it in terms of x. Well, what is u? U is equal to sine x. So I'm going to replace u with sine x. And so this is going to give me 2 sine x to the 1/2 minus 2/5 times sine x to the 5/2 plus c. And here's my answer. And I hope this video helped. Check out the video, the first example, for kind of explain the guidelines. And I'm going to have some more examples of these trig functions. I've decided to do them all in one video per problem. And hope you'll check out my other videos too. Thanks.